Good morning. Let us begin. Today we are going to sort of look at chapter 3 and hopefully finish it. And then we'll start looking at chapter 4. Chapter 3 and chapter 4 are connected. In the last class we started chapter 3. Chapter 3 is a basic discussion about the model of demand and supply, where we would discuss about what the market demand looks like, what the market supply looks like, how do you derive market demand, how you derive market supply, and finally how you derive equilibrium. After talking about showing how to derive market equilibrium, we are going to see some comparative statistics which explains what happens to market equilibrium when demand or supply or both of them changes. This is a fairly straightforward chapter in the sense that you have seen most of these materials before, and but we are going to take sort of like an empirical approach to chapter 3 and our discussion about demand and supply. I think this is one of the biggest value addition of this discussion of demand and supply in our economics of organization. Now, in any other principal level courses, the model of demand and supply is always discussed, and we know how to derive demand, we know how to derive supply, but we also want to understand how to derive these market conditions, how these concepts are derived from an empirical perspective. And that's what we're going to do today. We are also going to do some in-class problems, and then hopefully time will permit us to move on to chapter 4, which is a more detailed description about the mechanism of demand and supply and how the market model can really help us to understand economics of organization. Now you can understand that since our discussion involves trying to understand the organization of a firm, one of the most important decisions the firm makes is how much to produce and how much to charge. Therefore, the empirical aspect of the demand-supply model is important for a firm because what we do as a researcher or an academician is that we develop these models in our sort of classroom environment, which sometimes have no real life implications, but for a firm they really need to be able to use these concepts from an empirical perspective. So the driving force behind our chapter 3 and chapter 4 is empirics. And we start today with defining what we call a market demand function that defines the demand relationship that a firm faces or a market faces. In a very general notational form, the demand curve is usually written as follows. The first variable has two notations. One is a superscript and the other one is a subscript. The superscript is usually indicating whether we are looking at a demand curve or a supply curve, because demand curve and supply curves looks very similar to each other. The subscript is usually referred to the good in question. Here we are using a random variable, good called good Y. It could be anything else. Now the left-hand side variable is actually the quantity demanded for good Y. In this case, the example is taken from the textbook. This is an example of automobile, and we are trying to understand the automobile industry or the demand function for the automobile industry. We can argue that the demand function, where the quantity demanded, is a function of several variables in the market. One is that it is a function of the price of the good, the automobile. By PY is the price of the good itself. PX is the price of related goods. So this could be other goods that could be related to the automobile that you are buying. I stands for income, obviously an important variable in defining demand. Small I is usually the interest rate that also can affect the demand for a certain product. That I is usually coming from the bank interest rate that probably has a macro element to it, and AD is a variable that microeconomists are increasingly stating is a demand function. AD is called advertisement. So advertisement also affects quantity demanded. Now, in this very generic form of a market demand function, our objective from a theoretical perspective is to understand how each of these variables affect quantity demand, something that we can do easily in a theoretical environment. But that is not sufficient because sometimes theory can lie. In order to really understand the effect of these variables on the demand for a particular product, we need to be able to find empirical evidence and see what the data actually is telling us about the relationship. But our discussion will always start from a theoretical point of view. Theoretically, in order to sort of advance our theoretical understanding, we can write this function in a more general and simple form. This is a linear function where the variables on the right hand side is affecting our quantity demanded sort of linearly. So how these variables on the right hand side, which we usually call independent variables, affect our dependent variable, which is quantity demanded, is a theoretical question. Also, it has an empirical question. So theoretically, the relationship between these independent variables and how they affect quantity demanded are going to be indicated by these so-called coefficients A1, A2, A3, A4, A5, and N6. Now, as a researcher, one should always start with assigning some kind of signs of these coefficients, meaning that one can always start with some kind of theoretical justification as how each of these variables affect our quantity demanded. Some of them are intuitive, some of them are not that intuitive. For example, we can argue that our A1 is negative, meaning that the price of the good itself has a negative effect on the quantity demanded. When the price goes up, quantity demanded goes down, and vice versa. Makes sense? The one that is not obvious is the price of the related goods. So, if you remember your principles of microeconomics, we said that there are two kinds of ways goods could be related. They could be substitute goods, they could be complementary goods. If X is the substitute good, then the price of X will be positively related with the demand for good Y. Why? Because we know that when two goods are substitute, like Coke and Pepsi, and the price of Pepsi increases, the demand for Coke increases. And when the price of Pepsi goes down, demand for Coke goes down because they are substitute goods. Are we all clear on that? So, and if these two goods are complementary goods, in this case they are not, because this is taken from the textbook where the X good that we are looking at is actually a substitute good. If they are on the other hand complementary good to each other, then P of X would be negatively related with the demand for good Y, because remember what the complementary good example was. The classic example of a complementary good, which we are going to look at in chapter 4, is argued by the guy who came up with this in the 1950s, is a person and a shovel. Are they complementary goods? You know what a shovel is, right? Yes. This Russian economist who really had a very crude way of looking at the world, his name is Leontiev, and today we are going to look at his contribution to our economics, for which he got a Nobel Prize. Argued that the shovel and a person are complementary goods. A shovel cannot work without a person cannot work without a shovel. In our principles of microeconomics, we talk about sugar and coffee, which we argue are complementary goods as well. If the price of sugar goes up, demand for coffee goes down, because you do not buy sufficient sugar because the price has gone up. As a result, you also don't buy sufficient coffee, right? So in that discussion, this sign would be negative, but since we are assuming the related goods are substitute goods, the relationship between between Px and Q dy is positive. What about income? I. What do you think the sign of A3 should be?
Positive.
Are you positive about that?
If it's a normal good.
Very good. So the discussion is not straightforward, right? It can be negative and positive both. If it is negative, we know that our good is an inferior good, which means that as my income increases, I buy less of that good. If the sign of A3 is a positive one, we know that our good is a normal good. So it is for the empirics to figure out what kind of sign do we have. Are we all clear on that? What about A4? A4 is the coefficient for population. How do population affect quantity demanded? I think it is safe to say that the sign of this probably is positive. Because as population increases, quantity demanded increases. More people, more demand. What about interest rate? How does interest rate affect your demand for products?
The interest rate is high, then maybe spend more because your savings will have a larger effect, or your savings will earn more, so you can spend more now.
Okay, you are in the right direction. When we want to assign some kind of sign for A5, we need to understand saving. Okay, someone else have any comment on this?
Financing.
Sorry?
Financing.
Okay.
Financing part.
Yeah, please elaborate on that. I think you are on an interesting track too.
If the interest rate is higher, you'd be less likely to finance or buy the car.
It's going to cost more in the end if the interest rate's high.
What kind of cost?
Opportunity cost to be higher as well, because if you put it in a deposit at a bank, you're going to get
Okay,
more
your
money
argument
on it.
is exactly similar to what he said. We're going to come back. We're going to add these two ideas. But I was trying to understand about financing part. Opportunity cost is not here. This is not the producer, right? If there is a change in interest rate, it obviously affects the cost of production for our producer, right? Something which we're going to look at in a minute when we look at supply curve. But for the consumer, interest rate offers a chance for opportunity cost, right? Okay.
I was just going to say when interest rates are higher, that means the investors will invest more.
That's the supply side argument. That's the production side argument. This is demand. This has got nothing to do with producers, right? Yeah. Okay. So when we are trying to assign a sign on A5, we need to understand savings. Yes. Right. We know that when interest rate increases, it increases the opportunity cost of buying something, right? Because you are giving up too much. When interest rate increases, which means that consumers want to save more, right? Rather than spend money. If they want to spend money, their demand obviously goes down, right? So when interest rate increases, saving increases, consumption goes down, demand goes down. So the sign of this particular coefficient should be negative. Interest rate should have a negative impact on your demand, quantity demand. So which means that if interest rate goes down, your demand increases. If your interest rate increases, your demand goes down. What about advertisement? If you are a firm, this probably is the most important variable in your quantity demand. Does spending more money on advertisement increase demand? Yes. Most of the literature, and that this is a vast array of literature, argue that it is true. Most of the research argues that the sign on A6 is positive. There are still debates on that because economists who say that advertisement has a positive impact on how much firms can sell, meaning that an increase in investment really increases quantity demanded, argue that it's probably not the amount that is affecting demand, but probably the information it is creating, and there is a debate about that. But at this level, I think we can safely assign a positive sign on that. That's our theoretical discussion. That's our hypothesis. Now, this is an empirical course, which means that a mere hypothesis is not sufficient. You have to find actual empirical evidence to support your hypothesis. Your textbook will show empirical results of this demand curve that actual regular economists, very famous people, looking at actual data, were able to get, right? In a future class, we are going to show how they went from a hypothesis to an actual estimation, because we then have to talk a little bit about regressions and statistical technique. That's for the future. I think it is not. I think I will try to spend some time after chapter 4 to talk about estimation. When they put this demand function into tested with actual data, they found the coefficient A1 to be negative, they found coefficient A2 to be positive, they found coefficient A3 to be positive, they found coefficient A4 to be positive, they found coefficient A6 to be negative, and they found coefficient A5 to be negative, and they found coefficient A6 to be positive. What I'm trying to point out is that almost all the estimated values of the coefficients are consistent with our theoretical proposition. This is very, very encouraging. Okay? Yes?
But as interest rate, I thought we learned from macro theory that depending on your consumption smoothing motive, if you're saving, then interest rate goes up. You don't have to save as much to be able to consume more in the future.
Right, and I think that macro element really, well, there are several things here, right? This is firm level data, right? What we taught in macroeconomics is macroeconomic effect of interest rate on savings, which means that it has to somehow work out the savings of everyone in the economy whenever interest rate changes. From a firm level, I think the opportunity cost argument is sufficient enough to get this kind of results. I can assure you that when you look at the aggregate data on savings and interest rate, their relationship should be, I don't know. When interest rate increases, it all depends on the income effect and substitution effect, right? And so one cannot really make a conclusive statement there. It will depend on the empirical side. If the empirical side argues that your income effect is dominating your substitution effect, then an increase in interest rate should reduce savings and vice versa. Okay, those of you who have not taken intermediate macroeconomics, you can forget about what we just said. He just took an intermediate macroeconomics course with me. Okay, makes sense. So from a micro perspective, from the firm level data, what we find, the estimated results are very consistent with our theoretical understanding. I think this is an encouraging fact that all the microeconomic theory that we have learned are not a total loss. Okay. Now, after you define a quantity demand function, notice that this quantity demand, unlike your principles of microeconomics, can be both a demand curve for an individual firm. It could also be a demand curve for the entire market. Why? Because you see that from a demand perspective, demand curve really do not change from firm to market, right? Remember, our demand curve for the market was the horizontal summation of individual firms' demand, which means that we assume that in a market, everyone faces similar kind of demand function, but everyone should face different kind of demand. So, whether this equation is a firm demand or a market demand really depends on what these variables are, right? Are we all clear on that? If this is a firm's demand, then this advertisement would be the advertisement made by an individual firm. This population is the population that particular firm has access to. This income is the income of the consumers who are buying that firm's product, and so on. So for the market, this could be the entire market for that particular product, right? So the distinction is a very simple one. So a firm, after defining this kind of production, this kind of demand function, probably first tries to estimate their own demand, and then if they have a very good understanding about the entire market, they can also derive the market demand, because both of them are important informations, right? Obviously the market demand will be always larger than individual firm demand, because market most of the times consists of more competitors. But the basic idea is the same. Any question? Now, I strongly recommend, and I actually will sort of force you guys to bring your textbook from the in class from next class. Okay, you have to bring the textbook in the class, because a lot of discussions that we're going to have are going to directly come from the textbook. Okay, so what the textbook does is that it provides you with a table where, if you have this estimated equation, provided the data the table 3.2 provides, you can really estimate the market demand for this particular product. Why? Because your table provides you with values for P, PX, I, population, I, and AD. Do you all understand that? Notice that once you know these, you can calculate the, you can actually get the actual demand function for the market, right? Right? So what are these values, by the way? If you are indeed given some data, what kind of data do you think they are? What information on AD, I, population, I, PX do you think you need to provide? Let's say this is a demand curve for a market. So for that market, what kind of information do you need on AD? This is advertisement, right? As I mentioned that, AD is advertisement. What kind of information do you need?
How much they're spending on?
Like on an average level of advertisement, right? Because market demand is actually not demand by an individual firm, but it's actually a weighted average of the demand for all the demand faced by all the firms. So it's an average concept, right? Something that we're going to put more emphasis when we look at actual regression analysis of this. But for the time being, I think let's have an operational idea that all these variables that we need to define our demand curve are going to be some average values of these variables, right? Once you have those, which your table has, your textbook has, you can substitute those values and you can come up with what we call a demand curve estimation, where if you have values for PX, you have values for I, values for POP, I, and AD, you can substitute all those values. They are going to be multiplying these coefficients, and you are going to have Q is equal to going to be 23,000 big number minus 500 P. And that's your demand curve, a standard demand curve for the market. What have we done? We have substituted the other variables of the market as average variables, and we have established a relationship between quantity demanded of a good with its price, and this is the demand curve. Not only that, we have also shown conclusively that the relationship between price and quantity demanded is negative, indicated by the coefficient, which means that this is truly a demand curve. Now in the last class, I argued that although demand curve is usually written as this way, where quantity is a function of price, in order to replace that, expose that, show that in a graphical setup, we usually represent price as a function of quantity. So if we do that, if we change the signs and do modifications, our demand curve in a different formation would look like that. Where what we just did, we took the coefficient, we took the this particular term on this side, to put Q on the other side, and we divided everything by 500, and we get another form of the demand curve. They are identical, by the way. We are just representing Q as a function of price. This is actual demand, and in the second case, you are representing P as a function of quantity, which is convenient for us to draw this demand curve in a graphical setup. And that's exactly what you see in the slides. In the slides, we have drawn the demand curve as P as a function of Q, so that the vertical intercept is this big 46,000 something, and the slope of this demand curve is 0.002. Okay? Yes.
I had a question. If we're talking about interest rates on an average level, that would have to mean that that's not the federal funds rate. So how would that be related to savings if that's the average interest rate to finance a car?
So why do you say that it is not federal funds rate?
Well, because you said that it was an average interest rate.
Yeah. So most of the interest rate in the economy follows the federal funds rate very closely.
Okay.
So
well, it talks in the book about how they use anywhere from 2.9% to 8%.
it's true, but you know,
and stuff like that.
right. So what is your intuition? Your question is a valid one, because we are trying to use empirical tools, right? We want to really know how to estimate demand. So let's say you are a firm, you want to estimate your demand. The values for population, values for AD, values for I, they are pretty much accurate ideas. I probably is the average income of the economy, right? Advertisement is the average advertisement expenditures. Population obviously is the same. What about I? I would argue that if this is a demand curve for a market, I think federal funds rate is a good approximation. It's not a big deal. Because of two reasons. Yes, it is true that if the I is not properly, if the value for I is not properly used, you come up with a wrong number for I. How does it going to change your demand curve? Stay with me for 2 minutes. Let's say I mistakenly use the same interest rate on my savings rather than use the federal funds rate, or the other way around. How will that affect my demand curve? It will, but how?
The magnitude, so like that 1 billion, the coefficient.
It will affect the vertical intercept, right? Right? It will affect the vertical intercept. Do you understand that? Right? Is this important for a firm to really correctly estimate their vertical intercept? Yes, it is true. But the mistake is very minimum. Why? Because part of the main reason, driving force of why firm wants to estimate a demand curve is to really understand the comparative statics side. Comparative statics refers to situations when one of the variables change and market demand changes. And a firm really would like to have a good understanding about how this variable changing affects their own demand. And I think that whenever, if you are using savings rate on your, interest rate on your savings as opposed to using federal funds rate, the magnitude of those changes are going to be identical. The level is not the same, but the magnitude of the changes are going to be identical. Does it make sense?
I think what he's saying is that to purchase a car, most people have to finance it, and so that financing rate is going to go up as interest rate.
It is true, but notice that regardless of what interest rate you use in your estimation of the demand, on the differentiation side, when you are measuring competitive statics case, they are actually not that relevant. Right? Yes, if you want to be like really accurate in estimating a demand curve, which I don't think is that relevant for a firm, and that probably will change the vertical intercept. I agree with you. So again, the book at the end of the textbook gives you reference of 7 or 8 papers. One of them just focuses on that. Just experiments with different kind of interest rate and see how the comparative static experiments changes. It does not. And that is based on a macro observation that we are already familiar with, is that regardless of what different interest rate you have in the market, they might look all different, but they all are what we call, moving, they have co-movement, they have very strong co-movement, they move in the same direction. Okay, so that's my market demand curve. Then we go to my estimation of the demand curve. Okay, obviously when you are able to, after you are able to estimate a demand curve, the next thing that you need to do is you need to understand how can your quantity demand change, right? So, how can my quantity demand change?
Any of those things?
Sorry?
Any of those things change?
No, only when price changes, when my will my quantity demanded changes. So whenever there is a change in quantity demanded, it will mean that price changes, nothing else does. So in terms of your principles of microeconomics, this will be just a movement along the same demand curve. But then we also want to understand how can my demand change. Now my demand will change when price does not everything else does. In most of the cases, we are interested, at least in this chapter, we are more interested in, at least for your exam, we will be more interested in trying to understand how demand changes. For example, the book talks about an experiment when your interest rate I decreases from, sorry, I apologize. Yeah, so as an example of this, imagine that your interest rate is 8% and your price of the product drops from 34 to 30 to 26. So nothing else changes, just your interest rate, just your price level changes from 34 to 30 to 26. Let's spend some time looking at this graphical feature. This is very important. Let me first explain what this graph is telling us. This graph is showing us 3 different market demand curve for the same market or for the same firm. Each of these demand curves corresponds to a different interest rate. Interest rate is one of the factors that will shift your demand curve. The interest rate associated with the lowest demand curve is 10. The interest rate associated with it is 10%. This is interest rate 8%. This is interest rate 6%. Okay. Notice that whenever if you just compare these 2 demand curve, as the interest rate decreases, your demand curve shifts up, right? So because they are all shifted version of the same demand curve. So we are still consistent with the fact that interest rate has a negative effect on demand. As interest rate goes down, demand increases. We're going to mainly work with our 8% interest rate, so that's the middle demand curve. At 8% interest rate, we are not. Let's just increase that a little bit. Why am I? Sorry, okay. Can you guys see it now? Okay, so at 8% interest rate, that's our starting point of interest rate. as the price changes, you will move along the same demand curve. For example, when the price was $34 or $34,000, because it's the car of a car, you can use that equation, this one, to calculate quantity demanded for that product, right? So just substitute 34,000 here. It will show you that the quantity demanded at that price is 6 cars. When the price goes down to $30,000, you can use the same equation and you can show the calculation that the quantity demanded is going to be 8. And when the price is $26,000, you can also show that the quantity demanded is going to be 10. Okay? Any question? So, what we are just doing is just looking at the same issue that we have looked at in Principles of Micro, but looking at it in a more from an empirical side, is that when prices change, you just remain on the same demand curve. You just move from one point of the demand curve to another point. So this is just a movement along the same demand curve. But things change when you have some other variable other than price changes. Okay? Now, whenever any variable other than price changes, you are going to have what we call change in demand, which means that your demand is going to shift either to the up or right. Yes?
When you say that nothing else does, do you mean like when price changes and everything else remains equal?
Yes.
Okay, cool.
Right. And this is kind of important because and I wanted to reserve this discussion for regression, the actual empirical part of this course, but let me just point that out anyway. The demand curve that we are actually estimating here, where we are starting with a hypothesis that our quantity demanded is just a factor of 1, 2, 3, 4, and 5 variables. This is an assumption, by the way, right? In reality, there could be 1,000 other variables that could be important for your demand, right? Notice that in this particular demand curve, there are no macro variables, as he was trying to point out, right? There has to be some kind of expectational term, right? Because your demand really is affected by expectations, which is completely absent there, right? So, when we are carrying out this, competitive static stuff where we are trying to estimate change in quantity demanded, or when we are trying to estimate change in demand, we are making very, very powerful and strong assumptions, right? When quantity demanded changes, it is going to come only when price changes and everything else. Everything else means everything else that is in our model remains unchanged, right? That could be really, really imprecise estimation of change in quantity demanded, because when price changes, some other variables which is not reflected in our model could change, right? For example, when price changes, people's expectation might change. Are we all clear on that? Make sense? Okay. So that's an assumption that we are making. So in case of a change in quantity demanded, we are going to assume that every other variables in our model is unchanged, meaning that they are at their original level. At the original level means these have to be on the average level of the economy, right? So this is going to be average population, average interest rate, average aggregate advertisement, average income, average price of the related products. In that situation, when price changes from 34 to 30 to whatever, price goes down, we see quantity demanded increases. Quantity demanded, when prices go down, we see quantity demanded continues to increase. Okay. Now, when there is a change in other variables, the other exogenous variables or independent variables, we are going to have shift of the demand curve. The most common one, which is very important for your exam, is when interest rate changes, because interest rate is an exogenous variable. When interest rate changes, you can see readily that it's shifting the demand curve. When interest rate goes up from 8% to 10%, your demand curve shifts to the left or down. When interest rate decreases, your demand curve shifts up. Okay? Any question? Okay, now if this is, so this is a discussion about our demand side, how to define a market demand function, how to estimate demand function, and how to conduct changes in quantity demand and change in demand. The next one is to move to the supply side. Can I delete all these? Okay. So the next topic is going to be, again, similar to the demand curve, is to first define our market supply function, which again will start with the hypothesis that we have a market supply curve that could be either for a firm, it could be either for an industry, it could be either for a market, doesn't really matter, they all have the same form. The format is going to be like this. We are going to define quantity supplied as QSY, where S stands for supply. It is going to be a function of some variables that we know are important. First of all, PY is the price of the good in question. PX is the price of related goods. W is one of the price of one of the factors, mainly wage. S is the price of another factor, which is the cost of raw materials. I is interest rate, and E is the cost of energy. So W, S, I, these are all price of raw materials. So let's just separate them, put them together, and put I on the right side. So you have price of the good itself, price of the other related goods, 3 price of raw materials or inputs, and then you have interest rate. Is interest rate, so what is interest rate for a firm? What is interest rate for a firm? Right, so I actually also is the price of a factor that a firm uses, which is the capital, right? So therefore, W wage, S price of the raw materials, E price of the energy, which is like price of oil, and I interest rate. These are all price of the factors of production. Okay. Now this is interesting because, again, just like the demand curve, we have somehow ignored the role of expectations. We have ignored the size of the market. We have ignored population. A lot of factors, but what can we do? This is how they are talking about this, right? Now, let's try to put some theoretical intuition behind how these variables are related to the quantity supply of this particular good. This is automobile. Again, supply of automobile. We believe that the price of the automobile is positively related to the quantity supply. There should not be any confusion about that. What are the price of the related goods? How do you think they affect the supply?
Increase.
Sorry?
Decrease.
Why?
Is dependent on the relationship again.
Right. So just want to be absolutely certain what I'm talking about here. Just give me 1 minute. I forgot to write down what X is in our supply curve, so that when you go home you don't get confused. So the supply curve, supply curve, supply curve. Yeah, the price of related products. So PX, this is the price of related products. So you're saying that it again depends on what kind of related products are, right? Because they can also be supplements or complementary to each other. So let's say if they are, let's say the price Px has a positive impact on the quantity supplied. So what kind of good do you think they are?
Substitutes.
So the price of a related product increases and the supply of this good increases. Okay? So can we say that they are substitute goods here? I think it makes sense because then it shows the level of competition that you have between these two goods. They could be negative if they are complementary, right? What about W, wage? What kind of effect do you think wage has on quantity supply?
Negative.
Are we all clear there that this is a negative? Because if wages increases, it increases your cost of production, so you supply less. What about S? This is the price of, I think, one of the other factors. That should also be negative, right? The price of energy, that should also have a negative effect. Now, let's talk about interest rate. What do we know about how interest rate affects supply? Any thought on this?
Negatively.
Why?
It's the cost of borrowing, so it can be percentage of cost.
So this is clearly cost of borrowing, right? And when interest rate increases, remember firm is actually borrowing money to finance their expenditures like investment, right? Because this part of this transaction takes place in the factors of production market. When interest rate increases, firms find it more difficult to borrow. So if interest rate increases, firms borrow less, they produce less, they supply less. So this should also be negative. When we estimate this equation, and we find, and you can check the book, that all our intuition about the signs of this variable and how they affect the quantity supplied are consistent with our empirical, with our theoretical hypothesis. Again, just like the supply curve, demand curve, if you take the average value of all these variables, which is provided in a table, you will come up with a supply function which is going to look like Q is equal to minus 52,000 plus 2,000 P. You can also rewrite it as price as being a function of Q. If you do that, it's going to be 26,000 plus 0.005 Q. Supply curve written in any of these formats are consistent because they indicate a positive relationship between price and quantity supplied, and hence it's a supply curve. It shows law of supply. This is the actual supply curve. This is the supply curve that we draw for convenience. So that's the supply curve. Now, just like the change in supply, quantity demanded and change in quantity supplied, we can also do the similar kind of competitive statistics in the supply curve. You can think about change in quantity supplied, which will happen when the price of the good in question changes, and you can have a change in supply when the price of the good in question is unchanged, but anything other than that changes, like interest rate or the price of raw materials, if any of this changes. The one that is more a little bit important is to understand the effect of interest rate on supply. When interest rate change in supply. So when interest rate increases, how do you think supply curve responds? Based on our hypothesis, we know that the interest rate is negatively related to quantity supplied, which means that whenever interest rate increases, your supply goes down, which means that your supply shifts up, right? And when interest rate goes down, your supply increases and your supply shifts down. Okay. Is that true? What we are now seeing is three, sort of empirically estimated supply curve. They are all shifted version of the same one. The reason why that is true, because these supply curves are same supply curves with just three different levels of interest rate. Everything else is unchanged. The only thing that is different between them is the interest rate. Notice that as you increase your interest rate from 6 to 8 to 10%, supply curve just shifts up, which means that supply goes down. This is exactly opposite to the demand side. The shifting is similar, right? In case of, sorry, I apologize, it's not exactly opposite, it's the same. So we now see that the effect of interest rate on both the demand and supply are identical. When interest rate increases, your supply goes down, your demand also goes down. When interest rate goes down, your demand increases, your supply also increases. Okay? Let us now, so we are basically done with the material that is discussed in the PowerPoint slides, but that is not sufficient because I think the PowerPoint slides were not well written for this chapter. We are now going to do, what we are now going to do is we are now going to understand the basic stuff in this chapter, which is to understand equilibrium. Okay. So how do you find equilibrium? You find equilibrium first graphically by equating demand curve and supply curve. So at a point where demand curve and supply curve intersect with each other is the point where the equilibrium will be found. So market equilibrium is going to be found where quantity demanded is equal to quantity supplied. So all you have to do is just derive use the two functions that we have just derived. We derived an equilibrium price, and we have derived an equilibrium. I apologize. We derived so our equilibrium is found where quantity demanded is equal to quantity supplied. So remember our demand curve was written as 23,000 minus 500p, and our supply curve was defined as minus 52,000 plus 2,000p, and if we solve this, we are going to get equilibrium price, right? So once we equate demand and supply, this equation only has one unknown, that's P. So if you solve it, you get equilibrium price. And if equilibrium price is used to substitute either the demand curve or the supply curve, you get equilibrium quantity. Right? Graphically, the equilibrium quantity is found at the intersection between demand curve and supply curve. And you can do that numerically by just equating these two equations, and you will find that the equilibrium price is going to be 30,000 and the equilibrium quantity is going to be 8. Our P will be given from this mathematical calculations, and our Q will be given when you substitute P in either the demand function or the supply function. So it's a very straightforward process. Sometimes we are not only interested in equilibrium price or equilibrium quantity, we are also interested in situations when things like this happen, when quantity demanded is greater than quantity supplied, or when quantity supplied is greater than when quantity demand is less than quantity supplied. These are very important and empirically plausible situations. When quantity demand is greater than quantity supplied, we call it a shortage, and when you have quantity demand is smaller than quantity supplied, we call it surplus. So in your next homework, you'll be given some numbers, and you'll be asked to calculate these shortages and surpluses. Okay. Any questions so far? So far, everything looks straightforward, and I think they are. The last part of the core component of this chapter is to do this so-called comparative statics. This is of utmost importance. Competitive statics, you have seen that in your principles of micro and other micro courses, where we change some economic phenomena, such as change in the income of the consumers, or change in the price of related goods, or we have changed the price of one of the raw materials, and we wanted to understand how this kind of changes not only affect the demand side or the supply side, but how it affects the equilibrium altogether. You can do this from a very, very rigorous numerical perspective. The rule of thumb, and it's very, very important, because graphically looking at competitive statics should be a piece of cake for you guys now, because you have seen that so many times. From an empirical perspective, it is very important to notice what is changing and how it is changing the market. Because competitive statics is sort of like an experiment that we carry out in our market model, where we usually go through these three steps. Whenever, and the step one is to figure out which side is affected, how is affected, and what is the effect. These three steps are very important, because you can be given some random competitive statics proposition, like let's say I tell you, hey, what happens to this market equilibrium when average income of the economy suddenly increases? So if this is the competitive statics you are asked to do, you have to first figure out which side is affected. So since this is an income, you know that income affects demand side and it does not affect the supply side. Then you have to figure out how it is affected by identifying whether this is increasing demand or decreasing demand. An increase in income is supposed to shift the demand curve up. So after you figure out 1 and 2, 3 is easy, as long as you know how to do the numerical calculations. In order to do 3, we have 2 rules of thumb, and they are very, very important. In order to carry out these 3, please remember 2 rules of thumb. The rule of thumb is very simple. When you change demand, keep supply unchanged. And when you change supply, keep demand unchanged. This is the only way we can carry out competitive statics. Because notice that now you will be dealing with 2 equations that summarizes the demand side and the supply side. And when you are talking about a factor that affects only the demand side, you have to assume that that factor by default doesn't affect the supply side and vice versa. Otherwise, competitive statics cannot be carried out. Any question? Let us now start looking at actual problems. Okay. The first one that I'm going to look at, because I mentioned that I would, is, and it talks about this, right? Competitive statics, study how changes continues until a new equilibrium is reached. Okay, so remember, this is our original demand supply model, where the original market equilibrium was here. The price was $8, and the price was 30,000, and the equilibrium quantity was 8. Okay, now okay, so this is my original market equilibrium, where this is demand curve corresponding to 8% interest rate, and this is supply curve corresponding to 8% interest rate as well. Okay, so what would happen if interest rate, let's say, suddenly goes down to 6%? Graphically, it's very simple. So we know that. I'm just a little bit curious. Yeah, please give me 1 minute. I just want to figure out why did I have. Yeah, that's fine. I think there's a mistake in the graph. Let me draw this in a graphical setup. I think this is wrong. So this is my original market equilibrium, right? And this is my demand, this is my supply. Let's say that at this demand, my interest rate is 8%. At this is my interest rate. This supply curve is when the market interest rate is 8%. So the market is in equilibrium when the market interest rate is 8%. We get a market equilibrium price and we get a market equilibrium quantity. Now my question is, suddenly interest rate I decreases. What happens?
When you shift demand and supply.
Very good. So that's why this is wrong, right? When interest rate changes, remember, if you look at your notes, interest rate is a function, is a independent variable for both demand and supply, right? So if you do that, you know, and interest rate goes down, your demand. Notice that interest rate affects both your demand curve and supply curve negatively. So when interest rate goes down, your demand curve will go up. Let's say this is 6%, and your supply curve will also. Am I doing it right? Yeah. So if your interest rate decreases, your demand increases, and your supply will also increase. So this will be 6%, right? So if this is the original equilibrium, the new equilibrium would be at point B. Now, from a graphical perspective, we know that when both demand curve and supply curve shifts in the same direction, what can we say about the equilibrium price and quantity? Which one is certain and which one is not certain? Just by looking at the graph, do we know what will happen to equilibrium price and equilibrium quantity?
Quantity would go up. What happens to the price?
Very good. So whenever the shift of both demand curve and the supply curve is in the same direction, meaning that they either both go up or they either both go down, we are always sure about quantity. We know for sure that equilibrium quantity is going to go up. The effect on price is ambiguous. Why? Because you can see, I can draw 3 different graphs. In one graph, price could actually go up. In another graph, price could actually go down. And in another case, price could actually remain unchanged. How do you make sure which one is the correct answer? So, yes. So, when you are given this comparative statics, you will find new QS by plugging the new interest rate in the original supply function. Are we clear on this? You will find the new QD by plugging the new interest rate in the original demand and supply function and then equate them. Right? So with the new interest rate, once you find, let's just add a new, because notice that both of your demand and supply is going to change. So after you find new demand, new supply, you equate them, you are going to find new price, just like we did before. It will give us our new price level. Once you plug the price, it is going to give you the quantity. Right? Make sense? So that was the sort of like the one experiment. Let's now look at some in-class problems. Okay, the problem that I'm going to look at first is from your textbook. It asks you to do some trivial calculations, which I'm going to ignore. I'm going to try to mainly focus on how we can have demand curve and supply curve, and how you can use these equations to find equilibrium. Yes?
Sorry, going back to finding the price, so what makes the price different? You said that you could get 3 different values for the price.
It mainly depends on what is the magnitude of change in the demand curve and the supply curves. Your demand curve and supply curve could change in such a way that after equating the the new demand curve and the new supply curve, you actually find a price which is identical to the previous price. So it stays on the same level. But you notice that even when price stays at the same level, your demand curve and the supply curve have changed. The functions have changed. So your quantity will change, but the price could remain unchanged, which is a theoretically possible one. Just for I want you guys to struggle with that, and when you go home, try to follow these steps. Graphically, to answer your question, you can have the one that I think you are interested in is the one where price actually remains unchanged, right? That's what I think you want. So let's say this is the original price and this is the original quantity, and for this very specific example, we are seeing, I'm going to cheat in this case, where my supply curve, this is original supply, this is original demand, is going to shift such a way, and the demand curve is going to shift in such a way that the price is unchanged but the quantity increases. And this is for sure. We know that quantity will always increase when demand and supply both increase, right? The one that we are not sure about is the price level, because price level will, so if you remember your principles of micro macro, it really depends on the magnitude of the change in demand and supply. It really comes back to the coefficients on that interest rate, right? You can have situation where the shift in the supply curve would be much larger, let's say like here, right? And you can see clearly that that would actually reduce the price. You see that? On the other hand, you can have a relatively larger increase in demand with the same kind of change in supply, and that could raise the price. So price effect, or the effect on price, is ambiguous. The effect on quantity not. It's always going to go up. Any question? Let's look at the next problem. So we have a demand curve and a supply curve. Please make sure, and I make this very sincere request. Whenever you see equations like that in the exam, I might not actually put D and S there, which means that I'm not going to tell you which function is what, but you should know from just by looking at the function which one is a demand curve and which one is a supply curve, right? The one where for quantity and price are negatively related is the demand curve, and where the quantity is positively related with price is the supply curve. So let's say we have a system of equations. This is actually a system of equations, and so this is P31, and I have quantity demand which is 17500 minus 10,000 P. We have quantity demanded 25 plus 7,500 S. You are asked to calculate equilibrium. In this question you are not. This is a more trivial problem, but I will give you equations like this and I will ask you to calculate equilibrium. We know in equilibrium quantity demand is equal to quantity supplied. So you directly equate the two sides, so the two left-hand sides as follows, like we did before. And if you solve this, you are going to get price which is going to be 315,000 divided by 85,000. I apologize, I was kind of lazy, I didn't calculate that because I don't have a calculator. But that will be your price. Once you get the equilibrium price, you can either plug it here or you can plug it in the supply curve. You will get your equilibrium quantity, because equilibrium quantity is the same for the demand curve and the supply curve. Okay. So that's one kind of question you will see in the exam. Also, you are going to see that in the homework, next homework, which I'm going to upload. Okay. Let's look at P33. Please read the question. So what do you think?
Is the increase in housing prices all else equal, or is it?
What was the question?
We're supposed to say whether an increase in housing prices would decrease or increase the quantity demanded for housing.
No. You are just. This looks like trivial experiments, but they are not, because in the actual problem you are going to see more complex problems. So let's say you are given a demand scenario and you are asked to verify how these kind of effects would affect the market, right? So this is the demand curve, this is the market for housing, and whenever there is an increase in the housing prices, would that really affect demand and supply? This is a trivial question, right? But we want to really be able to sort of formalize this idea so that you have, if you have more questions, in a more complex question, you are able to answer them. So this is the two demand and supply curve for the market, right? Regardless of what the market is, right? So this is the price of the related goods, income, interest rate, population, AD. These are all independent variables. For the supply curve, you have a bunch of input prices, price of related goods, and the price itself. So we have established the fact that this is always negative. This can be negative or positive. Income is positive. Well, it can also be negative and positive depending on whether you have negative, whether it's a normal good or inferior good. Interest rate is negative, population is positive, advertisement is positive, this is positive, this is positive, these are all negative, right? So A is trivial because whenever there is an increase in the house price itself, it just causes a movement along the same demand curve, so it's a change in quantity demanded, no shift. What about B? We did that a couple of minutes ago, right? So you can have the question in several setups. I prefer these kind of questions because they are qualitative, because they allow you to really write down whether you, and allow me to see whether you know these things, right? So whenever there is a fall in the interest rate, what would happen?
Shift.
There will be shift in both demand and supply curve, and we know what the market equilibrium quantity is. It's going to increase, and we do not know what the market equilibrium price is going to be. It could increase, it could go down, and it could remain unchanged.
the quantity will decrease. Right.
Whenever the interest rate goes down, your
Sorry.
your demand is going to increase, your supply is going to, both of them are going to shift to the right, so equilibrium quantity will go up.
I thought that was the opposite of
Right. And equilibrium, right, okay. So that's another kind of question that you might see in the exam. The last one is very important one, because it allows us to look at some other aspect of this chapter. Please read the question carefully. Is everyone done with the question? So two marginal costs, and the industry actually is characterized by these only two firms, and this is competitive. So price is equal to marginal revenue. So how do you determine the supply curve for each firm? Express price as a function of quantity and vice versa. That's trivial. When you have marginal cost like that, marginal costs are important. Can anyone tell me why marginal cost is important? What's the relationship between marginal cost and the perfectly competitive industry? Right. So since this is a perfectly competitive industry, it should be common knowledge that these marginal cost curves are nothing but the supply curve of a firm. So you can literally get the supply curve just by playing with these functions. Okay, so the way we are going to do this, the marginal cost is just shows you, how the quantity of output affects the cost of production. So there is no representation of price, and in order to get a supply curve, we need a price, right? Right. So what are you going to do? You know that every firm maximizes their profit when marginal cost is equal to marginal revenue, and set that equal to price, right? So therefore for firm O, this is going to be, price is going to be equal to their marginal cost of production. So it is going to be 350 plus 0.0005 Q0, and for firm Y, this is going to be 150 plus 0.0002 QY. Okay. So that's the supply. That's actually, if you think about it, that's actually the supply curve of these two firms, right? It shows the relationship between price and quantity, right? But then, are we all clear on this as to why they are supply curve? Now, we have to. The question also asks you some other very interesting thing. So let's just do a basic problem. Now, if based on these two functions, you also can calculate the equilibrium price, right? Because you just equate those two. I apologize. Sorry. So from the first equation, you can write the stationary supply curve where quantity supplied is a function of price, and you can write it as, if you manipulate that equation, it's going to look like that. And your supply curve for the Y firm is going to look like this. So once you find individual supply, Q0 and Qy, the actual supply, let's just call it S, is going to be Q0 plus Qy. So we are doing a horizontal summation, right? You have done this before. You find firm level supply, and when you get the market supply curve, which is Qs, you just add them up, right? So we can start from marginal cost, we can find the supply curve for individual firm, and then we can find the market supply curve just by adding up individual firm supply. Now this question also asks you some very interesting situation, right? For example, calculate the quantity supplied by each firm at prices 325, 350 and 375. 325, 350 and 375. When the price is 325, how would the supply curve for Q0 look like?
They don't split.
Who said that? Absolutely, right? When price is 325, your numerator is negative, which means that at that price, firms make no supply, right? Supply curve doesn't exist for a firm, 0 when the price is 325. For firm number Y, at price 325, they would supply because they actually have a positive number. Do we all see that? What about 350? At that price, would supply curve exist for Q0? It won't. The supply curve for Y will exist. When the price is 375, supply curve exists for both of these firms, right? So now, therefore, you can see that the supply decisions or the market supply curve actually is as follows. Until and unless the price is equal to 350, so if price is less than 350, Qs is just equal to Qy, right? When price is less than 350, the market supply curve consists of only supply of the second Y firm. When price is greater than 350, Qs is equal to Qy plus Q0. So you see that the supply curve actually has different regions, right? It's not a straight line supply curve. It's quite dynamic, quite interesting. Any question? Are we all clear on this, what I just did? Okay. So I'm done with chapter 3. I have like 5 minutes. I always run out of time, but that's fine. Let me just introduce chapter 4, the next chapter. What we're going to do in chapter 4, in chapter 4 we're going to look at this demand and supply again from a more empirical perspective, in the sense that I know that almost all of you have taken intermediate micro, right? Although I should stop saying that because people don't like me saying giving reference to previous courses, but this chapter is again a repetition of intermediate micro, but we're going to go along with this chapter anyway. We need to understand this. What we're going to do, we're going to first show how we actually find this demand curve, because this demand curve is not coming out of thin air. There is a optimization process behind demand curve as well, and that optimization is utility maximization. Our consumers maximize their utility based on some kind of budget constraint they have, and that utility maximization behavior really gives rise to a demand curve. We're going to show how utility maximization maps into a demand curve. Then we are going to sort of try to understand how changes in the budget constraint or changes in other aspect of the market really affects our consumption pattern that we go through. So we'll talk about budget constraint, we will talk about indifference curves, we will talk about optimal consumption, which is found at the intersection between the budget constraint and the indifference curve. Then we are going to spend the remaining part of that chapter just trying to calculate elasticity, various different kinds of elasticity. They're very important because firms spend huge amounts of money trying to estimate elasticity. Elasticity is important for policy making because it shows exactly by how much revenue can get affected whenever prices change. So thank you very much. I'll see you guys tomorrow. How are we doing with the homework, by the way?
It's not bad.
Okay.
Still waiting on it.
Okay, I have uploaded the actual question. So even if you cannot get the book,
Well, I'm talking about some records tomorrow.
yeah, please. So have you ordered a textbook? The bookstore does not have a copy.
Well, I've already ordered it.
Oh man,
Isn't it fine for us to work together on homework stuff?
sorry.
Isn't it fine if we work together on homework?
Absolutely. I mentioned that specifically in the syllabus. The number of students cannot be more than 4, by the way.
When I went to the bookstore there,
This is just unacceptable.
don't have any more until tomorrow.
You can get the, I bought it online.
I bought it online too now, but it won't get here until probably Wednesday at least.
Yeah, but before Wednesday, I'll upload another homework. I will also do the similar thing. I'll copy and paste part of the textbook so that you can read it from there. Thank you.
Thank you.
You're sort of working on homework. I was looking at the last number. I shouldn't be too long. You already don't know.
It's not brother. Yeah, I was due Friday night. Right?
Or the one that's due tomorrow.
Oh no, I haven't even looked at that yet.
It's 30 questions.
Is it really?
Yeah.
No way.
So boy.
What's up, brother?
What you doing?
What is this? Oh, I didn't get this.
Did you?
Yeah.